The first question I got wrong asked what the magnitude of the impulse exerted on the ball by the floor is if the ball falls vertically to the floor and hits it with a speed vi and then rebounds with a speed vf. So we just used the momentum impulse equation. So our initial momentum is just going to be negative mvi because the ball is heading downward. Then we add our impulse, which is just j, and that's going to be equal to our final impulse, our final momentum, which is mvf, and that's going to be positive because the ball is going upward. So we just solve for j. We add mvi to both sides, and we get mvf plus mvi. We can then take the m out, so we have m times in parentheses vf plus vi. So that's our answer. The next question I got wrong asks which of the following expressions is equal to the average force exerted on the block by the projectile during the collision. So the first thing we gotta do is write out the impulse momentum equation. So in the initial state, the only object that has momentum is the projectile, and that momentum is m1 vi. So we'll write that down. Then we add our impulse, and in this case we just write it out as the average force times delta t. That's going to be equal to our final momentum, which is since the projectile is embedded in the block, we write them as 1. So we have m1 plus m2 times the vf, which is our final velocity. Now we just solve for average force. So we subtract m1 vi to the other side and divide both sides by delta t. So now these two terms cancel out, and we're just left with m2 vf over delta t, which is our answer. The next question I got wrong asked for the force acting on the body at position x, given the potential energy of the body as negative mgx plus 1/2 kx squared. So in order to solve this problem, we just take the negative derivative of that function, because the negative derivative of a potential energy is the force. So when we evaluate this derivative, we see that for the first term, negative mgx, that's just going to be it's just going to be mg, because the negative gets canceled out, and m and g are constant, so you take them out, and the derivative of x is just 1. So we have mg. And then as for second term, 1/2 and k are just constants, so you take those out, and the derivative of x squared is just 2x, and the 2 and the 1/2 will cancel out. And then, of course, since it's a positive term, that will make it negative. So we have negative kx. And that's our answer. The next question I got wrong asked to find the acceleration of a 2-block pulley system, in which we replace block B of the system with a block that's twice the mass. So to solve that, we have to find the acceleration of both systems before you replace the block and after you replace the block. And to do that, we need to use Newton's second law. So first thing we're going to do is use Newton's second law to find the acceleration of the system before you replace block B with a block that's twice its mass. So as you can see, I've already set it up and I've already began solving for the acceleration. So we can simplify this further. So our acceleration is 3 over g for the initial system. As for the system after you replace block B with a block that's twice its mass, I'll be doing that now. We basically use Newton's second law again to solve for the acceleration again. So that's our acceleration for the system after we replace block B with a block that's twice its mass. So in order to find the ratio between the accelerations, we basically just got to divide the original acceleration by the new acceleration. And if we do that, we get, so we have 3g over 5 multiplied by the reciprocal of the original, which is just going to be 3 over g, and we get 9 over 5 as the ratio. So in terms of the original acceleration, the new acceleration is just going to be 9 over 5 a, which is the original acceleration. So the next question I got wrong asked for the center of mass of a uniform wire, and it gives us a couple of points in the diagram and asks us at which point is that center of mass closest to. So to solve this question, we have to use the center of mass formula in the y direction and then solve from there. So as you can see, we get that our center of mass in the y direction is L3, and this is basically closest to point B. So point B is going to be our answer. So the next question I got wrong tells us that the momentum of a moving object as a function of time is given by the expression p equals kt to the power 3, where k is a constant, and it asks for the force causing this motion. So we know that force is equal to the derivative of momentum with respect to time. So all we got to do is just take the derivative of the expression the question gives us with respect to time. So since k is a constant, we don't have to worry about that, taking the derivative of that. We can just pull that out. As for t to the power 3, the derivative of that is just 3t squared. So we have k times 3t squared. And that's just going to equal 3kt squared. So that's our answer.